I recently did a series of videos about nuclear power. The upshot was going to be that we don't need thorium and we don't need small modular reactors. We just need to build and operate third generation reactors well, and we'll have safe, economical nuclear power. I was going to cite the example of the Westinghouse AP1000 reactor. Really, it's much more than a reactor. It's a recipe for a nuclear power plant, which sounds great. It's got loads of passive safety features, and there's nothing wrong with that. It also features modular construction. Parts of the reactor are fabricated off-site and installed module by module. This sounds great, doesn't it? Like the Boeing 787, the AP1000 looked great on paper, but actually getting the value from all of the advanced features was a lot harder than the leadership at Westinghouse or the various companies that owned Westinghouse recently, or the utilities that bought this reactor from Westinghouse, or the engineering firms hired to build the reactors, or the oil field equipment makers who were building the modules for the AP1000 reactors thought. To give you just one example of how reality intruded on the AP1000 design, those reactor modules are big and heavy, and transporting them isn't trivial, and they needed to arrive and meet engineering specs, acceptance tests in the right order and on time. And if they don't, they pile up at the reactor site because they have to be installed in a certain order. And if there's rework, who's going to do it and where? And if anything goes wrong with producing, transporting, or assembling them, it causes huge delays and cost overruns. It was a nice idea, but it never actually delivered on the concept of a factory-built reactor for a standardized power plant. The AP1000 modules require barges, superload trucking, and the largest heavy lift cranes on the planet to move and assemble these modules. These aren't Lego pieces. This isn't a factory-built reactor. It's really a very conventional reactor with a lot of expensive transportation in the middle of the project, making project management dependencies much more complex. Like the Boeing 787, this led to tens of billions in cost overruns at two reactor projects, one in Georgia and one in South Carolina. Westinghouse went bankrupt and abrogated its fixed bid contracts to build the reactors, leaving the utilities and their ratepayers holding the bag. It all comes down to bad management with an abysmal lack of foresight. And that is why we can't have nice nuclear power plants, or nice airplanes for that matter.